here are a few more examples of factoring the difference of two squares pattern. Right, so remember, the difference of two squares pattern is when you see I guess a binomial here that is literally the difference of two terms that are being squared, right? So a term that's being squared minus another term that's being squared, okay? And the pattern for this, for factoring this, is just a plus b and a minus b, right? So it's basically, it's switching around when we had this a plus b, a minus b, and then FOILed it, and we got this, right? We're just kind of working backwards now, okay? So in part A, we have m squared minus 9, so the first step is to write this as the difference of two terms that are being squared, right? So I could write this as m squared minus, and I can write 9 as 3 squared, okay? And so, sorry, that's a bad little exponent there. So I could write this as this, right? And then I know that I can use that special pattern and write this as m plus 3 times m minus 3, okay? And so that would be our final answer. Okay, remember with these questions that we're doing, we can always check with FOIL, right? So m times m is m squared. My outside terms will multiply to negative 3m. My inside terms will multiply to positive 3m. And last times last will be negative 9. And so when we combine like terms, I'll just get m squared minus 9, which is what I started with. And so I know that my answer is correct. Okay, looking at part B, right? Remember, how we can identify this is if this 49 is a perfect square and 81 is a perfect square, which they both are. And so let's write this as exactly that, the difference of two terms that are being squared. Okay, so 49q squared, I can maybe write this as 7q, the quantity of 7q that's squared, and 81, I can write this as 9 squared. All right, and so there's my a term and my b term, so now I can just use my special pattern. I can write this as 7q plus 9 times 7q minus 9. Okay, and this is my final answer. Okay, obviously, again, we can check this with FOIL, right? So 7q times 7q will give me 49q squared, right? My outside term here will give me a negative 63q. My inside terms will give me a positive 63q. And last times last will give me a negative 81. So when I combine like terms, this is going to be my final result. And so I know that I'm correct. Okay, and my very last one here, 12 minus 27x squared. Okay, I look at this number 12 and 27, and right away I say, you know, neither of those are actually perfect squares. So let's see if we can take out a greatest common factor. Okay, now this is the part I sense is going to be hard for most of you. So factors of 12 here, I have 1 times 12, maybe 2 times 6, and 3 times 4. Factors of 27, I've got 1 and 27, 3 times 9. Can't think of any other ones, right? So the greatest common factor here actually looks like 3. So I'm going to take out a 3, and I'll divide each term by 3 to see what would actually be left over here. Okay, I know that 12 divided by 3 is 4. Okay, I know that 27 divided by 3 is 9, so this is what we'll end up getting, right? Now this is a little better, right? Because I recognize this number as a perfect square. I also recognize 9x squared as a perfect square. So now I can write this as, you know, I can write 4 as a base that's being squared. So I'll write this as 3 multiplied by, I'll write this as 2 squared minus, and then, you know, 9x. I could write 9x squared, I could write that as the quantity of 3x being squared. Okay, well now I'm just going to write this as a plus b and a minus b, right? So this is going to be 2 plus 3x and 2 minus 3x. Okay, and this will be my final answer that I can just go ahead and check with FOIL, right? So I'll leave the 3 out here for now. Okay, I'll do first times first will give me 4. My outsides will give me a negative 6x. My inside terms will multiply to positive 6x, and last times last will give me that negative 9x squared. Okay, so when I combine like terms here, I'll get 3 times the quantity of 4 minus 9x squared. Okay, and then finally when I go ahead and distribute my 3 here, I'll get 12 minus 27x squared. Okay, so I know that my answer is correct.